Hey everyone, and welcome to Building SaaS on AWS, the flagship show for building SaaS on AWS. My name is Gunnar Grosch. I'm a developer advocate here at AWS, and if you're building or planning to build a SaaS product, this is really the show for you. What we do here every other week is that we dive deep into SaaS-specific topics so you can learn more about building SaaS on Amazon Web Services. And every other week, I bring on guests, SaaS experts, to talk about those deep dive topics. And this week, I am super happy to be joined by Stephen Atwell and Dan Peach from Armory. Welcome to the show, fellas.
Hi, thanks.
Hi, Gunnar. Good to be here.
All right, so we always do the quick round of introductions, so let's do it this time as well. Stephen, you go first.
Hi, I'm Stephen Atwell. I'm a principal product manager here at Armory. And fun fact about me, I also, in my free time, build open source garden planning software.
That was a fun fact, Stephen.
That is fun.
Dan, you go next.
Hi, I'm Dan. I'm a software engineer at Armory. And my fun fact is that I was in a 90s cover band in college. I played the bass.
I think we have to get to both of these topics throughout the show. But before that, I'm going to tell the viewers that this topic or this show is, of course, about Armory. And we're going to talk about safe continuous deployment to Amazon EKS using Armory. And as usual, we want this show to be very interactive. So if you have any questions, any comments, just put them in the chat, and my expert guests will do their best to answer those questions, of course. And we're also joined, as usual, in the chat by other SaaS experts. I believe we have both Bill and Anthony with us today. All right, so maybe we should start by talking a bit about Armory. So can you tell the viewers a bit about what Armory is?
So Armory is a company that is trying to, kind of solve the continuous deployment problem for all companies. So we got started commercializing Spinnaker, which is an open source project that came out of Netflix, and getting it so it was useful by companies that were not named Netflix. And then we started looking at kind of like the 80-90% most common use cases for what people are doing, and asking ourselves the question of, how do we make these extremely simple, extremely straightforward, and just work? Because the reality of the matter is, like, continuous deployment and doing it well is still too hard. So that's what Dan and I have been working on with Armory Continuous Deployment as a Service.
Yeah, I think that continuous deployment as a service is something we'll, of course, dive deeper into throughout the episode. But I think it's a very interesting concept, and I'll be interested to know more about our viewers and know how they are working with deployments to EKS and to Kubernetes today as well. So if you have any comments around that, please post them in the chat for us. So maybe let's talk a bit about continuous deployment as a service. And what does that mean for a user of Armory?
Conceptually, when you say something's as a service, you're going, we're providing this to you. We're focused on your success. We want it to be as easy as possible for you to be successful. So when we say that with continuous deployment, instead of just handing you, a CD with a piece of software on it or a download link and saying go, and step one is figure out, like, how do I even get it up and running in the first place? We want to give you a simple experience where you can effectively just say, hey, here's my Kubernetes cluster, here's my application. I want to deploy with a canary strategy. Here's my existing monitoring system. Make sure my monitoring is healthy while deploying, and it just works. So that's kind of where we're trying to get to. And continuous deployments as a service is also our SaaS offering that is built on AWS.
Exactly. So let's talk a bit about Armory and the product, the customers you might have, and different types of use cases. So why do you see that customers are partnering with Armory today?
So there's a couple big reasons there. So one of them is they're looking for, simple declarative deployments. So there's two big dichotomies in the deployment world of how you configure things. There is imperative patterns where you basically say, do step A, do step B, do step C, do step D.
Mm.
And when something in your process changes and you need to add a step, um, you need to figure out the right place to put it. And sometimes it breaks another step downstream. Things tend to be a little bit more brittle. The other pattern that has been rising more recently is one of declarative. Rather than saying do step A, do step B, do step C in great detail, you define a goal and a set of requirements to reach that goal. So, we want to have the new version running in production. Hey, that's the goal. What are our requirements? Well, it needs to go through staging. It needs to run some integration tests. These are requirements to reach that goal. And then you let the software figure out the best way to do that. And by defining your processes at those higher levels, they tend to be significantly more resilient to change. We also have, I mentioned, deploy to staging, run integration tests. So, there are several different styles of CD solutions out there. And, one of the first things that a lot of our customers get started with is kind of that like multi-environment, like dev stage prod, promotion
Mm.
lifecycle, making sure smoke tests run and pass before every deploy to prod. And then we also have customers who are using us for things like canary and blue-green deployment strategies where, hey, if you're deploying to production and it costs you millions of dollars a minute if your website's down, you want to be doing things to minimize the risk of deploying to production. So, we also offer advanced strategies for that and work with our customers to make sure production is always stable while also allowing them to ship more often.
And well, looking at it from a broader angle, then how do most companies deploy to different cloud environments today?
So from what I've seen, I would say by far the most common pattern for how people deploy to cloud environments is custom scripts,
Mm.
typically written via a Jenkins or a GitHub Actions or an AWS code build, um, and those are very complicated. They're not that resilient to change. When you have things change, they inevitably break. Um, they often have one person who knows them really well, and when that person leaves the company, suddenly no one understands what that build script is. So if they do break or need to change, it's hard. Um, and then the other one that's often there is actually manually. There's a lot of companies that do continuous delivery or even do continuous deployment to like a dev or a staging environment, but don't do it all the way to production.
Mm.
And yes, they're kicking off every code reaching like an integration environment within engineering, but there's still to this day a lot of companies where they're shipping to production once a quarter,
Right.
and that slows down their delivery of value to their customers. It slows down their ability to compete against the competition.
Have you seen that using Kubernetes, like we see more and more companies do it, has that made it more common to have these customized scripts, or has it made it perhaps even less safe to do it that way?
So off what I've seen, like far and away, a lot of people are trying to move things to Kubernetes.
Mm.
It makes certain aspects that have historically been done in these customized scripts declarative and automated, because Kubernetes itself is declarative and automated. So it
Yeah.
does simplify some of that automation. But like I haven't seen like using Kubernetes versus not doesn't like increase the risk level. And a lot of the strategies people are doing manually or in custom scripts, today on top of Kubernetes, things like canary and blue-green deployments. Like I remember encountering those concepts back when I worked in IT in the late 90s. Like the strategies are the same. It's just the technologies and how they are kind of automating the job of the, historic IT operations team that has changed.
Right. And you also mentioned, for instance, blue-green deployments and canaries. Well, maybe we can mention a few of the benefits by using those types of deployment strategies for perhaps making it safer with deployments.
Yeah. So high level, if anyone's not familiar, blue-green deployment is where you stand up a new version of your application in parallel to the old version. Sometimes people do things like, hey, expose the new version to a preview URL, so like we can run some smoke tests against it, or even we can hand validate it. Like, it's kind of impressive what percentage of the world, when they realize their a new version of their product is broken, is when they pull it up in production and they see a 404 error. So hey, if that's how you're detecting it, you use a preview URL, you look at it, you make sure everything like looks happy. Over time you want to automate that. And then, assuming everything's happy, you send the traffic over to the new version, but you keep the old version around. So, cool, all your traffic's hitting the new version of the application. If something goes wrong, you still have the old version around, which means you can just redirect traffic to it. Some cloud native applications, start and stop very quickly. Like, this is one of those goals of your microservices architecture. But there's still, production applications running this world that take, an hour to start a pod.
Right.
And if that's your product, having instant rollback is a very, very big thing. Canary strategies take this one step farther. So they stand up a new version, but instead of sending all the traffic over at once, they slowly trickle it over time. So think I've got a new version, old version of traffic of my application running, and I just want to send 1% of traffic to the new version. So one of my customers is a payments processor. If they have a bug, like, are they having payment transactions fail? If you think about some of these softwares, like, those bugs can be big deals, and if you're doing a high volume of transactions, that can get very expensive very fast. So decreasing the blast radius is something a canary strategy very much lets you do.
And in what way does Armory make those types of advanced deployment strategies easier then to implement for customers?
So both of those strategies would be examples of ones that our customers want all the time, that we basically have completely automated for how we run. Let me show you how one of those is configured in CD as a service. Can I share my screen really fast?
There we go.
Awesome. So here you can see a blue-green strategy. I mentioned that we're declarative earlier. So this is a list of things that need to happen before we redirect traffic. So,
Steven, sorry, could you make that a little bigger for me?
Oh, yes.
Thanks so much.
That better?
Amazing. Thanks.
Perfect. So here's a list of things that need to happen before we redirect traffic. So, this automated analysis is basically just running a query against Prometheus, make sure it's still happy. Shut down old version after. Hey, I mentioned for a blue-green, like, keeping the old version around so you have instant rollbacks. So we've got a couple automated health checks. If either of them fail, we'll automatically roll back. But then, hey, let's keep it around for a manual approval. Maybe we want to keep it around for 20 minutes. We can throw in just a 20-minute timer, have it automatically shut down after that amount of time. For a canary strategy, here you'll notice the set wait step. So this says send 25% of traffic to the new version. Here we've got send 50% of traffic to the new version. There's different options for how you send traffic. So, we support 3 different ways of doing this. They all use the same set of steps, and they're like 4 lines worth of config different. If you don't, basically there's this technology family called a service mesh, which is things like Istio and Linkerd and AWS App Mesh. And if you're using a service mesh, we can integrate to it and use it to route traffic. And that gives us very, very fine-grained of control, traffic control. If you aren't, there are some less fine-grained controls for how we can do based off how Kubernetes natively routes traffic, basically by stopping and starting pods. So this tells us, hey, send 25% of traffic. How you implement that is actually very complicated. And if you're trying to do a canary strategy via custom scripting, you're going to have a very large custom script just to do that 25%. And if, 6 months later, you decide you're going to adopt a service mesh and you want to switch to implementing that on top of the service mesh, you're going to have to go rewrite that entire custom script. Whereas with us, to adopt a service mesh, you come down and you add 4 lines that look like that says, hey, here's my service mesh, here's the technology, here's the service names to route traffic for.
Cool. And I just want to ask a question that I'm sure you're going to say it depends, but I often get this question when talking about deployments. How do customers choose which deployment strategy they should use for a specific workload? Should they go with Canary? Should they go with blue-green? Is there an answer for that isn't it depends?
So it depends. So some products out there don't like having 2 versions running side by side, both getting traffic simultaneously. In that, if that's your application, going and running a canary strategy may require making changes to your application. Oftentimes you can still get away with a blue-green strategy. So, it depends on your application. Canary strategies also tend to be more useful if your application doesn't, for example, have like long-lived network connections. So, we have a service inside that maintains long-lived network connections. Doing a 1% trickle on inbound network connections, if you're keeping network connections open for, hours at a time, isn't nearly as interesting as it is for like web requests.
So
yeah,
it depends.
It depends.
All right. So then, well, let me ask you this, maybe playing devil's advocate a bit. How does this differ from other popular tools for deployments?
So I would say it's a lot simpler. So I mentioned that there's 2 different flavors. There's imperative versus declarative. So that's one of the big differences across the market. So like open source Spinnaker, where Armory got our start, is an imperative deployment tool. This is all available as a plugin for it, which adds a declarative experience within it. If you look at something at some of our competitors, we've got several competitors who are imperative as well. There are other declarative tools. Most of the other declarative options for EKS run within a given single Kubernetes cluster. They don't have any kind of that like cross environment promotion validation stuff that I was talking about. Some of them are also, significantly more complicated. Like if you want to do something that is, of reasonable complexity, like, they give you a declarative framework, but it very quickly breaks down. So an example of that would be, let's say your application, you have 2 tightly coupled services. I've got 2 deployment objects. I need to roll them out together. If there's a problem, I need to roll them back together. Some of our big competitors don't natively support that. If you want to do that, you get to go write your own custom, typically imperative automation for it. That's just the default behavior for us. Like you just hand us a set of Kubernetes manifests and they're all rolled out and rolled back together. So those would be some of kind of high level differences. We're also SaaS. We have a very lightweight footprint in your cluster. So, some of our competitors use an operator model where, you run something in your cluster. It's pulling everything running in your cluster, looking for like custom CRDs that change. If you're deploying tens of thousands of objects in your Kubernetes cluster, that can wind up being a performance bottleneck that doesn't scale. We don't do kind of that whole active polling of your cluster. We run a very, very lightweight agent. All our business logic is in the SaaS elements, which means, you don't have to go, okay, cool, we want to upgrade. How do we go and get this upgrade pushed across all our clusters? How do we make sure when we do this upgrade, it doesn't break anyone? All of that just works.
All right. This became a sales pitch. It was meant as a technical question.
Sorry.
I brought it upon myself. So
I swear I'm not trying to be a salesman.
So everyone, if you just joined us, this is Building SaaS on AWS. I'm Gunnar, joined today by Steven and Dan from Armory, and we're talking about safe continuous deployments to Kubernetes and Amazon EKS. Now, I want to dive more into the architecture of Armory. And should we perhaps switch over to your slide then, Dan?
Yeah, let's do it.
So tell us a bit about the architecture for Armory.
Yeah, I think there's a lot of places to start. I think for me, like a good place to start is like thinking about how customers like get started with Armory, and then connect it back to this mess of squiggles over here. So one of my favorite features of this product is our agent. We call it the remote network agent, and I can tell already I'm going to end up calling it the RNA because that's what we call it all the time. And this agent sort of solves a long-standing hard problem at Armory, which is onboarding a customer or group of customers that have hundreds or thousands of Kubernetes clusters, and figuring out the networking between Spinnaker and their Kubernetes clusters, or in our case, our SaaS product and their clusters. And so the experience that we have for CD as a service is if you want to onboard a Kubernetes cluster, we spit out a set of kubectl commands or a Helm command, and say just run this against your cluster. You'll install an agent, and the agent will reconnect with CD as a service, and then we can go from there. You can just instantly start deploying to that cluster. So that's a really, really nice experience. And so this agent sort of helps with two things. So one is really easy, amazing onboarding. And then once you've been using CD as a service for a while, it's a network agent. It's not a Kubernetes specific agent. So Steven was just talking about sort of you have your deployment, and before you deploy to prod, you want to run some integration tests. All my integration tests for my imaginary company are on a Jenkins server running somewhere in my infrastructure. Do I have to expose like a public port for CD as a service to communicate it? No, the answer is no. Our remote network agent, you can call through that agent with a webhook to kick off those integration tests. So it solves a lot of problems for us and allows us to give customers a really nice experience. And
then, well, let's talk about a bit more about that connection part and networking part. So
sure.
How do you connect to private Kubernetes clusters?
Right. So the customer installs an agent in their cluster, and it makes an outbound call to our product, and it's actually a gRPC call. It's a bidirectional gRPC stream, and then in this diagram here, you see Wormhole, which is always a fun name, and Wormhole implements actually a SOC 5 proxy. So these other services in this diagram can all communicate with Wormhole as a SOC 5 proxy. So many client libraries, including the Kubernetes client libraries, will accept a SOC 5 proxy configuration. And so ultimately what this means is essentially we can just imagine that there's a TCP stream between Wormhole and the remote network agent and outbound. It's as if there's an outbound connection going from Wormhole to the remote network agent, but it's really TCP over gRPC. Yes,
Yeah.
Steven?
One small thing I want to add to that is, because we're connecting through the remote network agent and it's running in your cluster, like we don't need any long-lived credentials to your cluster. When we phone in through that remote network agent, we're able to just connect via the remote network agent service account running in the cluster, which means, what can Armory do in my cluster? Well, you've got the full power of Kubernetes roles and service accounts to do it. And Armory doesn't have a long-lived credential that could be lost. It has an inbound network socket that is coming from your infrastructure and which you control.
Yeah.
Well, yeah, and you call that Wormhole. I just have to say, I loving all of the names. Internal names are always fun to see.
Thank you.
So then, well, this is a SaaS show, and on SaaS shows, we always have to talk about multi-tenancy and isolation, of course. So can you maybe explain a bit how you at Armory look at that? How do you secure tenants in your solution?
Yeah. So I think we have a tenancy model that should look pretty familiar. I remember when we were designing the tenancy model, Stephen was always telling me, because and we'll talk about this, I'm sure, in a moment, we use CD as a service to deploy CD as a service. And Stephen was always telling me, you've got to keep, IT and, solutions engineers from taking down CD as a service. We have to build a rich enough authentication and authorization experience that they can, look at our stuff, but not take it down. So the fundamental objects are organizations and tenants. So an organization has many tenants. Users belong to organizations and can have org-wide roles, but also sort of tenant scope roles. And then client credentials, like long-lived machine credentials, belong to a tenant and can have tenant scope roles. So at Armory, Armory is an organization, but we have different product areas. CD as a service is one of them, and so our like production environment. And this doesn't have to exactly be how you structure things, but our production environment that we use to deploy ourselves is a tenant, and then there are other groups have their own tenants and deploying their own way.
Yeah, so you can kind of think of tenant as being an easy way to like give a different team a full copy of CD as a service where they can have almost full admin permission. And the only thing that we share across these configs is the authentication stack, such that, if your company is using, single sign-on, for example, you can configure that authentication stack once, use it across all those teams, yet still give a team kind of that full admin access to like its own copy of CD as a service.
So maybe we should, it's a good point to move into the actual tech stack to take a look at how you built Armory. I guess I can guess certain parts of it, but let's see.
Yeah, so we, a lot of the engineers on the team are sort of Java and Kotlin and Groovy engineers coming from Spinnaker, but we wanted to sort of evolve with sort of the DevOps community. And so these are almost exclusively now Go microservices. I'd say one of the most interesting parts of our tech stack is using Temporal as a workflow engine for long-lived executions. This was one of the sort of scariest problems to solve early on in the product. We didn't know how, a deployment is like profoundly long-lived and has interactions with users for like manual approvals, or if you're kicking off integration tests, which are asynchronous. This is a lot of state to manage and do correctly over time. So we turned to temporal for that as sort of the initial implementation of these deployments. What's nice now is that we actually use temporal for all sorts of things that we never imagined that we would. One of them, this is pretty straightforward, but we do canary analysis with temporal. So, checkpointing over time. I want to run a canary analysis that runs an hour. At the beginning of the hour, I'm going to wait 5 minutes, take a snapshot of the metrics, wait another 5 minutes, take a snapshot of the metrics. But if at any point, the metrics aren't looking good, just fail fast and end the canary, and then also end the deployment. And so it's very easy to sort of build these sort of long-lived workflows and executions with temporal.
And this doesn't show, but I'm guessing this all runs in Kubernetes.
Yes, it is all in Kubernetes. Yes.
And you alluded to it, Dan, but maybe that you are using CD as a service to deploy CD as a service. So maybe can you mention a bit about how you're using it yourself, and maybe even why you built it?
Yeah. So I think we started building CD as a service, and we had this idea that we wanted to have really easy to use like declarative deployment experiences, like the ones that Stephen was showing earlier. Deploy into this environment and change the traffic weights, and maybe do like a manual approval or a timed wait before incrementing traffic over time. And we initially did that just for one environment. And we talked to customers, and they said, "Yeah, this looks really cool, but I think we should expand this into multiple environments before we can use it." And so we realized that the threshold for a deployment tool and making it useful is quite high. It's very challenging to make a deployment tool, and there's a lot of features that you need. So we got into a very healthy practice of dog fooding and building the features that we felt it was necessary to have in a deployment tool for our own deployment tool, and making those features rich enough that we felt confident in deploying every time. So I remember talking to Steven, and he was like, what is it going to take? Because we were initially deploying the tool itself with Spinnaker, as you can imagine. And Steven was always asking, what is it going to take for you to move from Spinnaker to deploying yourself? I said, well, multi-environments, right? So being able to deploy from staging into production and having those complex deployment strategies in each environment. And then I realized, oh, wait, we have this suite of integration tests that runs in between staging and prod. How's that going to work? And so we went back to the drawing board and implemented the webhooks, asynchronous webhooks, so that we could kick off a suite of integration tests and GitHub Actions. So that was a long-winded way of saying that I think that the product has grown a lot from dog fooding and building the kind of deployment tool necessary to deploy a SaaS product successfully.
I think that's very cool. And the one you're using, is it the same as your customers are using, or do you have an internal version of it? It is.
It is. It's the same production environment.
Very cool. And then, Dan, you alluded to it, but maybe bull that you are using, or do you have an internal version of it? It is. It's the same production environment. Very cool. All right, so this is Building SaaS on AWS with me, Gunnar, joined by Steven and Dan, talking about Armory and safe continuous deployment to Kubernetes. And I think we're 35 minutes into the episode. I want to see something in action, Steven. I think that's up to you, right?
Yeah. Would you mind giving me a screen share?
Here we go.
Cool. So Armory CD as a service. When we got started, we started by initially building the ability to trigger it from a command line. So today we can trigger it a deployment from a command line, a GitHub action, or a Spinnaker plugin. And the reason why we did a command line to get started is you can run a command line from any CI system. So pretty much all of them. It's this easy to run. So I'm just going to start my deployment manually. I'm sitting in a checkout in my Git repo. And when I start a deployment, I basically hand Armory that YAML file I was showing you earlier when we were talking about blue, green, and canary. And it says, hey, here's where you find the manifest to deploy, and here's how I want them deployed. The CLI then gives me back a URL that I can navigate to in order to see the status of my deployment. Here, every box represents a environment. So a combination of Kubernetes cluster and namespace. So I'm deploying in this demo to 7 different environments distributed over 4 different EKS clusters. So my dev environment finished running. We're now deploying to staging and InfoSec. When staging finishes, it's going to use webhooks to kick off a GitHub Actions workflow that runs some integration tests. When InfoSec finishes, it's going to do the same thing, just with some security scanners. We're only going to move on to our production environments if those tests pass. If they fail, we'll cancel the deployment immediately. So you can see, looks like InfoSec is in the process of running its security scanners right there. And in just a moment here, we will be in production. All of our production environments are going to use slightly different strategies, and they're going to wait for manual approval before they deploy. Dan touched on our security model. I'll show you another thing we can do with permissions. So here you'll notice I can't actually approve this. It says approvals required by an organization admin. Well, I'm logged in not as an organization admin, so I can't approve it. But if I come over here and we open that same deployment, hey, here I've got approve buttons. So we're going to go ahead and walk through a few different environments. So the first environment I'm going to show you is this prod operator one. So we can deploy anything. Our advanced deployment strategies are tied to Kubernetes deployment objects today. But some companies are deploying, other things like Crossplane or Argo rollouts to their Kubernetes clusters. And those use what's called an operator model. You deploy a CRD and the operator actions it. So this environment's using an operator. It's going ahead and using Argo rollouts. So I just approved that. So we went ahead and we deployed the updated Argo rollouts definition. And now we're just waiting for it to finish because, hey, we need to wait for it to finish in case we have like a downstream environment that depends on this one. If I come over here to the Argo rollouts UI and I refresh, here you can see that like there's changes happening. There's now 2 versions. And if I click this promote button a couple times, it's configured to need some manual approvals. It's going to go ahead and finish deploying. And in a moment here, we'll have, 4 boxes. And at that point, this environment over here on the right will finish. So, if you're using an operator, you don't need advanced deployment strategies, but you do want kind of that cross-cluster validation and promotion orchestration, you can use us with an operator. If you do want those advanced deployment strategies that we were talking about earlier, we have those natively built in. So let me start by showing you what a blue-green looks like. So here for prod EU, this is going to use a blue-green strategy. And I'm going to go ahead and maximize this at this point. And for every environment, you can click in and see the details of what's driving that environment. So on the left here, you can see kind of the overall status, what's going on. So we're currently deploying the new version. Then we're going to run automated canary analysis. On the right, you can see all the details. So here's the new version. Here's the old version. What image version is the application running? What's the replica set name, pod health, etc. So the new version came online. It's currently getting no traffic. We're running a quick metric check to make sure it's healthy. And oh, hey, you can see we just sent traffic to it. So now our new version's online. Our old version's still around. So if I hit rollback, it would be instantaneous still right now. And we're running a couple more health checks. So we ran an automated canary analysis. And then we used that webhook functionality to kick off just a check of our logs. Everything passed. So I'm going to go ahead and hit approve and continue. When I do that, the old version is going to shut down. Until I do that, I can roll back instantly. And anywhere I'm doing a manual approval here can be fully automated. They make a demo easier.
And rollback in this case is for that specific environment only, right?
So when we roll back, what we will do is we will roll back that environment. We will roll back any other in-progress environments, and we will cancel deployment to any environments that are not started.
Mhm.
If an environment is fully finished, it will not be automatically rolled back by rolling back a different environment. So, imagine you're deploying to, 4 different production regions, and you realize there's a problem in your code. When you cancel that deployment and roll back, you want to roll back anything that's in process, and you don't want to start updating to the others that haven't started yet.
Makes sense.
So that's a blue-green. Then for Canary, I mentioned we've got a couple different styles of Canary with or without traffic management. So this Prod West environment is going to do a Canary strategy without traffic management. I'm not going to show you the whole strategy on this one. I'm just going to show you kind of the beginning and how we route that traffic. So here you can see the currently running version. In just a second, you're going to see the new version come up. But because we don't have a service mesh, we are using the number of pods to control how much traffic is running. So you'll notice the new version spinning up just one pod. In a second, it's going to spin down a pod on the old version. That'll give us a 25%, 75% traffic split. So, if you haven't adopted a technology like an Istio or a Linkerd or we can route traffic this way and give you the benefits of Canary deployments. If you have adopted one of those, we can also integrate with them, which has some advantages. It means you have much finer grained control of traffic. It also means that we can update that traffic much faster. So, when we're routing traffic this way, the speed at which we can change traffic is dependent on the speed at which your application can start a pod. So I'm going to run through the rest of the strategy with a service mesh just because it's a little bit faster. So here we are on the version with a service mesh. And in just a moment, you'll see that we'll spin up the new version at full capacity. And then we will update the traffic going to it along the way. Another thing I want to call out, I touched earlier on tightly coupled services. This is a deployment. This is a different deployment. So we're deploying 2 different tightly coupled deployments. When we roll back, they roll back together and they're being validated together. That's not something that all CD tools support, but it is something that a lot of our customers need. So here you can see 25% of traffic is going to the new version. We ran an automated Canary analysis. It passed. We're now running a webhook that's checking our logs for errors, and then we're going to increase traffic to 50%. When traffic goes to 50%, we're going to run another Canary analysis. This time it's going to fail, and then I'll show you that rollback you were asking about.
All right.
Incidentally, these guys are deployment objects. We've got various other objects down here too. So I touched earlier, we can deploy any Kubernetes object. Our advanced strategies are tied to deployments. So all of these guys can be in the payload as well. And when we roll back everything. So our automated analysis failed. Up here, I can see, hey, these are the metrics that I tested. I can click on one and see the values that came back from my monitoring. In this case, I'm using Prometheus. We currently support Prometheus, Datadog, and New Relic for our automated Canary analysis. And it's as simple as hitting rollback if I want to roll back. Any questions on anything I've shown you here, Gunnar, before I hit rollback?
No, I think it's very clear. So let's do it.
Cool. So I'm going to go ahead and hit rollback, and that's going to send all the traffic back to the old version and spin down the old. But then, as I mentioned, it's also going to roll back the other environments. So if I go back to that prod west environment, this is probably the most complicated one to watch roll back because it doesn't have full capacity of pods over here. So, in a moment here, you'll see that this one's going to spin up new pods on the old version before it shuts down the new version, just to make sure there's no negative impact of that rollback. So in just a moment here, the new version will go away. This is going to be the slowest faller environment. So once that's gone away, we're fully rolled back and back on the old version for all traffic. The other one I was going to show you is a little bit more of that YAML and how this is all configured. I'll just set this over kind of on the side where we can watch it roll back while I do that. Yeah. So here in that YAML, we have a few different sections. So this target section specifies the list of where you're deploying. So I mentioned we had like a few different environments: dev, infosec, staging, prod. Each one of those is a section here. For each section, we state which Kubernetes cluster is it on. These names are configured by your remote network agent when it connects. What namespace is it deploying to on that cluster, and then which strategy are we using. So for our dev, infosec, and staging, we did a rolling update. For our production, we used canaries and blue greens. And just checking on that rollback, you can see our rollback has finished at this point.
And for these targets, it doesn't really matter if this is running in, say, EKS in US East 1, or if it's self-hosted Kubernetes running in Dublin or something like that. As long as you use that agent, connected it, you can just define those targets here.
That is correct. So, we can deploy to any Kubernetes cluster. EKS, very common one, but, if you have a workload that needs to be in your private data center for some reason, we can connect to your private data center. It needs outbound internet access to, a couple ports on a couple URLs, and that's the only thing it needs.
Very cool.
We talked a little bit earlier about declarative configuration. So we've got this list of constraints that need to happen before an environment is deployed. So here you can see infosec. It's only deployed to if dev finished. And after it deploys, it runs a webhook that's got named security schemes. So, this is kind of that declarative level of configuration. If we wanted to add a second webhook, we just add it as a second list here. For our production environments, we have after deploying, I didn't show them, but I was sending Slack notifications on the side to myself, letting me know, hey, this deployment's done. Hey, this deployment's starting. Before it deployed, we needed that manual approval. So, hey, here's the manual approval. Which role is needed? And then, we only deployed to production if both infosec and staging finished. So that's kind of the level of, all the multi-environment, all of the webhooks, etc. For our strategies, we touched on them a little bit earlier, but they're in that strategy section down below. Manifests, this is the collection of Kubernetes manifests that we are deploying. So, we can take one or more files, anything Kubernetes can deploy, basically. So if you can deploy it with kubectl, you can just hand us the same file. By default, every file you give us goes to every target. If you wish to send it to a specific set of targets, you can optionally provide a target list, and it will only reach those targets. For our strategies, we talked through blue-green earlier, and we talked through canary earlier. I also had a rolling update strategy in use, and it's just sending 100% traffic to the new version. For our automated canary analysis, everything I showed you here was using Prometheus, but we support Prometheus, Datadog, and New Relic. And they basically just take, here's the query in my metric provider. As it's being used by your current monitoring, you give us that query, you give us a threshold for what we should consider healthy, and we check and make sure it's healthy. If it is, then we continue deploying. If it's not, we roll back. For traffic management, this is the extent of the difference between those two different canary environments. And then for blue-green, we have an optional feature where we can expose URLs through the UI if you've got Ingress set up for kind of an active service and a preview service, so you can like literally click a link in the UI to see them. So this is the configuration for that. For webhooks, the webhooks I showed you here, most of them were running in GitHub Actions. For Argo rollouts, we were using a lightweight microservice you can run in your Kubernetes cluster that basically just lets you run a command line. So for Argo rollouts, we were basically just waiting for the Argo rollouts to finish running via kubectl. And for all of the other webhooks, we were calling the GitHub Actions dispatches API and basically just going, hey, go run this workflow. Dan mentioned very briefly in passing that we support asynchronous webhooks. So we support both synchronous and asynchronous. And this is one of those like weird technical details that I think is actually really cool. So if you look at something like the Argo Workflows API, you call it, it starts a job.
Mm.
Now you need to like pull the job status in order to wait for it to be done or have it call you back or something. And, with a lot of the imperative tools, when they say webhooks, all it is the ability to call an API, nothing more. So, you call it, it starts, now you go write your custom automation that's pulling it. In our case, while we can call an API with no callback, we call them synchronous webhooks. We also have asynchronous webhooks. We can call a URL and then wait for it to call us back and tell us it's done. So we don't have to do any polling. And basically, at the end of your GitHub Actions workflow, you add a step that says, "Hey, call back to Armory." And that's kind of nice because it means you're not having to do a synchronous webhook where you're maintaining an open internet connection for the whole process you're running. And a lot of the APIs out there, such as GitHub Actions workflows, it interacts with really nicely.
Very cool.
So that's the entire configuration for everything I showed you. If you imagine writing a script to do all of that, it would be significantly more complicated than this simple YAML.
This is a simple YAML. But how does Armory, the CD as a service, make sure that the YAML file that I'm creating is correct? So when I want to deploy this one.
Yeah, so when you pass it to the CLI, we go and we validate that all of the fields in it we know what mean. If you're missing a field that's required, we'll tell you, hey, you're missing XYZ field that's needed. If you provide fields that we don't know what mean, we'll provide you with an error telling you, hey, you've provided this field that isn't understood. So we run those validations basically at that time. We also have several tools to help you build these. So our CLI has some template commands which can generate one of these, and then we also very recently in our UI started putting together some UI wizards where you can basically say, hey, here's the path to my manifest, here's my application name, and we'll just generate one of these for you. And we're kind of putting together a pattern of wizards where you can take one of these files and take the last one of these you use for your deployment, and you can say, hey, I want to add this feature to the deployment, add a webhook. Hey, here's the API I want to call, here's the inputs to it. And then we'll go add that and layer it into your deployment and give you back the YAML. So, we're trying to make it as simple as possible. So you've got the full power of a YAML that's designed to be edited by hand, but we also want to make it so that, when you're new to the system, you don't have to learn the YAML in order to get up and running with it.
Right. Yeah, well, I definitely need as easy as possible. So that sounds good for me. We are quickly approaching top of the hour. So starting to wrap things up. Very cool demo, Stephen, and very nice to see Armory in action. I have one question about Spinnaker. You've talked about Spinnaker a couple of times, and how much of Spinnaker is left in Armory? You talked about it as that was the beginning, basically.
Yeah, so we have 3 different product lines. We've got our self-hosted product, our managed product, and our SaaS product. Today, our self-hosted product and our managed product are extended versions of Spinnaker, and our SaaS product is from the ground up. So it is not built on top of Spinnaker. It is using the things we learned from Spinnaker, and it's really focused on how do we make it simpler so that, instead of going, cool, here's a deployment platform, we're going, cool, we can make your deployment easy. That whole what does CD as a service mean to us question from earlier.
Right. So, and we talked about Kubernetes all throughout this hour, but many customers have other targets as well. They're also using EC2, they're using AWS Lambda and so on. So how does Armory work together with other types of targets?
Yeah, so CD self-hosted and CD managed are built around Spinnaker. They're multi-target. They support a very large number of deployment targets: EC2, ECS, Lambda, all these things. For CD as a service, we started with Kubernetes. It's easily one of the most sought deployment targets these days, but it is being built with the intention of being multi-target. So, later on this year, we're talking about adding Lambda and ECS, and there are other targets we'll probably be adding longer term as well. We're prioritizing targets basically based off customer interest. So Kubernetes first, but unlike some of the other deployment tools out there for Kubernetes, it's not going to be Kubernetes only for long.
All right, sounds good. And then we didn't really touch, we talked about security a bit and how to connect, but can this type of solution help customers with compliance?
Yeah, so we have, when you think about any of like the major compliance controls, I'll use SOC as an example. They pretty much all require you to be able to like demonstrate auditability around changes to production. Did it have can one developer commit change, deploy it to production, and break the world without talking to anyone else? Or, hey, did someone else need to review that change? So we have customers who use us for that. So that entire UI can even be downloaded as JSON, and every single piece of information in there stored separately if you want, or you can access it in our UI where we can give you a list of every deployment of every app. You can click into any of them. You can see who issued any of those manual approvals. If you think separation of duties, hey, that only this role can approve a deploy to prod. Customers do that to enforce separation of duties. We also have customers who use the tenancy model that Dan talked about in order to ensure that, teams only have access to the minimum set of services and environments they should have access to. So, that can kind of enforce a principle of least privilege.
All right. So with that, it brings us to the end of the episode. I want to thank Stephen and Dan for waking up early and joining us here at Building SaaS on AWS. And I know my friends Bill and Anthony, they've shared links in the chat, how you can get started using Armory and also how to find it in the marketplace as well. Of course, it's available there. So Dan, Stephen, thank you very much for joining today. Great having you here.
Thank you.
I also want to say to everyone watching that we'll be back in 2 weeks, of course. And that time I'm going to be joined by Momento, so we can learn about how they've built their highly performant serverless caching solution. So you can make use of your databases fast and indestructible in only a few lines of code. So looking forward to that episode as well. All right, Dan, Stephen, thank you very much. Thanks everyone for watching, and hopefully see you in 2 weeks.
Thank you, Gunnar. It was a pleasure.